Hello, hello, Miss Farrellock here today. Y'all know I love to start with a good joke. How do you make 7 even? You take away the S, of course. Get it? 7. Take away the S. It's even. All right, so in this section, we are looking at Module 3, Notes H, Symmetry and Transformations. We're going to start out just looking at symmetry of functions. Then we're going to talk about what are called parent functions or library of functions, and then transformations of those functions. All right, so let's talk symmetry first. There's 3 types of symmetry we are going to look at in this particular course. Okay. First type, we are going to look at x-axis symmetry. Now, essentially what this means is that the graph is a reflection of itself across the x-axis. So, if we draw ourselves a quick little sketch here as an example, here's our function. It's not perfect. Let me fix that up just a little bit. Let's make it a little more accurate. I'm not the world's best drawer. Here we go. This is symmetric across the x-axis. If we were to fold this graph in half across the x-axis, it would line up on itself. Okay. Now, if we want to be a little bit more specific, let's say we have a point on this graph. Let's call it AB. When it is reflected across the x-axis, that corresponding point is going to be A negative B. So it's that Y value that changes to its opposite. Now, make note of something else here. If we think back to functions, remember functions pass the vertical line test? A graph that has symmetry to the x-axis will never be a function. This will never pass that vertical line test. All right, let's check out an example of symmetry to the y-axis. All right. Let's say we have the following graph. Let me draw that in blue for y'all like I did the previous one. Now, in this case where we're talking symmetry to the y-axis, we're saying that if we fold this paper in half left to right, both sides of this graph are going to lay smack dab on top of each other. But if we get a little more specific, let's say we have a point over here in the first quadrant, AB. That point, that corresponding point reflected across that y-axis is going to be negative AB. So it's that x-coordinate that is the opposite. All right, one other type of symmetry we're going to consider in this course at this point, and that is symmetry to the origin. Now, when we talk about symmetry to the origin, we are talking essentially 180-degree rotation. So, for example, let me switch to blue again. This would be an example of a graph that is symmetric to the origin. It has the point AB in that first quadrant, but when we rotate it 180 degrees around that origin, we are looking at a corresponding point of negative A, negative B. So notice that that x-coordinate and that y-coordinate both are the opposite. So it's that 180-degree rotation. All right, so let's just try a couple of these. And in these examples that I'm going to draw out for you, best I can, I want you to decide which of the following is true. A, symmetric with respect to the x-axis. B, symmetric with respect to the y-axis. And C, symmetric with respect to the origin. Or perhaps even D, none of these. All right, so first up, I am going to draw you a beautiful circle centered around 0, 0. And I want you to think about whether this is symmetric to the x-axis, the y-axis, the origin, or none. If you said A, B, and C, give yourselves a pat on the back here. So we are talking x-axis symmetry, top to bottom. I can fold this in half and it will lay on itself. I can fold this over the y-axis, left to right, and these two halves will match up. And I can rotate this graph 180 degrees, and it will match up on itself. So we get A, B, and C here. All right, how about this one? Next up, we have the following graph. All right, think about this. A, B, C, or D. Now, the shape of this graph is very similar to one that I just drew previously when we talked about x-axis symmetry. However, this graph is just like up by itself alone in quadrant 1. There is no symmetry here with respect to the x-axis, the y-axis, or the origin. Okay, so we get D in this case. None of these. Okay, think about it. If we were to try to visualize this symmetry over the x-axis, this graph is above the x-axis, but there's no reflection of it below. Same deal with that y-axis symmetry or that origin symmetry. All right, let's try one more. How about something like the following? A, B, C, or D here? What do you think? You should get C here, okay? This graph is symmetric with respect to the origin. If I rotated this piece that is in quadrant 1 180 degrees, it would perfectly line up with that piece that is in quadrant 3. Now, keep in mind, too, you can consider a point. If I have the point AB, that same point with symmetry around that origin is going to be negative A, negative B. That X and Y coordinate are the opposites there. All right, next up, we are going to look at... I got ahead of myself there. Whoa. All right, I'm just going to stop my video here because my slides just went way out of whack. But next up, we are going to look at the library of functions, or known as the parent functions. Part 2 coming right up.